Okay, so we are in Generalized Linear Models with examples in R, that book right there. Chapter 3, question 3.8. Get to it. There we go. Okay, so we're going to be looking at the lungcap data set, which is discussed earlier in this chapter at least. Okay, and we're going to do several things with it. So here's what we're going to do, but we'll just look at them as we come to those questions. So the first one is we want to fit a model where we're modeling FEV, which is one of the variables, where the only predictor variable or explanatory variable is smoking status. Okay, and then we're meant to interpret the findings, the coefficient from the analysis. So so first you'll need to install the package and load the package, the GLM's data package, and then call up the data, and then I'm calling that data D just to reduce my typing. And when you look at computer's being slow. Okay, so when you look at the data set, I've just pulled up the first 6 rows here with the head command. You see the variables. So again, we're modeling FEV, and in this first question, we're just going to use smoking status, which is a binary variable, 1 and 0, 0 for not smoking, 1 for smoking. So when I go ahead and run that, let's run that model. So I'm calling it model 1 or M1. I have my linear model, and I'm regressing FEV on smoking status with this data, and then we'll get the summary. Okay, and so here's the summary output, and here is the coefficient that we're meant to interpret. Okay, so roughly what is happening here, so remember that smoking is a binary variable. It's either 1 or 0. So what this says is that for smokers, FEV is expected to be, 0.71 FEV units. I believe it's measured in liters, or maybe, yeah, I think it's in liters. But 0.71 liters greater than non-smokers, okay, with this particular standard error, okay? So 0.71 plus or minus. So that's the expected difference between smokers and non-smokers. And then, this estimate is apparently statistically significant. So now next, we're supposed to do the same thing, but now we're supposed to model on all the variables. So FEV will be modeled on age, height, gender, smoking status. Okay, but we're not using any interactions here. Okay, so here's my second model. Now, if I want to grab every other variable in the data set, I can just use that period, and that says everything else. Let me run this one. Okay. So again, we're supposed to interpret the coefficient for smoking. Okay, so this guy right here. And so what this means is that after we account for these other explanatory variables, the estimate is that smokers, their FEV will be lower by about 0.09 liters compared to non-smokers with this particular standard error. Okay. But this estimate is not statistically significant. Okay, so that is our best estimate, but it is not statistically significant from 0. Okay, so that's that. And so now here on 3, we're going to do something slightly different. We're going to use the same model, but instead of modeling FEV, we're going to model the logarithm of FEV. Okay. Why? Well, the question does not ask us to explore why using the logarithm of the FEV, but presumably there is some nonlinearity in the FEV, which makes sense because FEV is a physiological measure, and there is no way that it is, well, it's probably lower bounded as well as upper bounded. Okay, so by taking the logarithm, by taking the logarithm of it, then we kind of transform that variable to conform more to the normality assumption. So I'm going to run that. Okay, and so once again, we have our coefficient values here, and now I'm interpreting this again, the same coefficient, but now this is saying that smokers are going to have a lower log FEV, right? So no longer FEV, but a lower log FEV by this much with this standard error, and this estimate is apparently again, all we've done is transform the outcome variable with a logarithm. Okay, and now we're meant to determine a suitable model for the data. Now this is a very open-ended question. Determine a suitable model. Well, a suitable model really depends on how you think all of these. It depends on your intention for the analysis and how you think the variables interrelate and so on and so forth. But it also seems to suggest that we should try to find a different model other than the ones that we've used. But when I looked in the back of the book, this is one of the few questions that has an answer. And so it just picked one of the models. Okay. Now the way it does it in the back of the book is it uses ANOVA for the third model, but that doesn't make any sense. What I am going to use in order to kind of pick from among these three is the AIC command. Using kind of information criteria among these three models. And so when we run this. So when we run this, you see that M3 has the lowest AIC score. Now remember that lower signifies a better fit to the data with AIC scores. Okay, so M3 has the lowest of these scores, and so this would be the preferred model based on AIC. Okay, okay, call that good.